Hello everyone and welcome to Roadmap. Today's topic is chemical equations and reactions part 2, and if you like the video, don't forget to click on thumbs up button below. You can also subscribe for more video updates, and you can also give your suggestions in the comment section below. So already we have gone through the introduction part and how to write a equation and how to balance them. So those who haven't watched the video, I would suggest that go back and check the video so that you will have a better conceptual understanding, and then come over here, because then you will be able to get the link of the concepts in a more better way. So coming to the types of chemical reaction. Now in class 9th we have learned that during a chemical reaction, atoms of one element do not change into those of another element, nor do atoms disappear from the mixture or appear from elsewhere. Chemical reactions involve breaking and making of bonds between atoms which produce new substances. So there is a combination reaction. Now in this there is an activity that take a small amount of calcium oxide or quicklime in a beaker, slowly add water to this and touch the beaker, as you can see in the figure. Do you feel any change in temperature? Now calcium oxide reacts vigorously with water to produce slaked lime, calcium hydroxide, releasing a large amount of heat. And in this reaction, calcium oxide and water combine to form a single product, that is calcium hydroxide. Now in such a situation in which a single product is formed from two or more reactants, this is known as the combination reaction. And there are some more examples of combinations reactions, such as burning of coal, formation of water from hydrogen and oxygen. In simple language, we say that when two or more substances combine to form a single product, reactions are called combination reactions. We also observe that a large amount of heat is evolved, and this makes the reaction mixture warm. Reaction in which heat is released along with the formation of products are called exothermic chemical reaction. Now there are some of the examples of exothermic chemical reactions, such as the burning of natural gas. Then the respiration is an exothermic process. Do you know this? We all know that we need energy to stay alive, and we get this energy from the food we eat. During digestion, food is broken down into simpler substances. Rice, potatoes and bread contain carbohydrates, and these carbohydrates are broken down to form glucose. This glucose combines with oxygens in the cells of our body and provides energy. The special name of this reaction is respiration. So, the decomposition of vegetable matter into decomposed is also an example of an exothermic reaction. Now, the reaction, this is all about the combination reaction. Now, coming to the combination reaction, CaO plus H2O, that these are some of the chemical reactions equations which I have written from the activities that we have seen in the previous, that CO quicklime plus H2O gives limestone gives quicklime, and then the other reaction, that is carbon plus oxygen gives carbon dioxide, and then the H2 plus O2 gives out water. So these are some of the chemical reactions of which are the combination reaction. Now coming to the decomposition reaction. Now take about 2 grams of ferrous sulfate crystals in a dry boiling tube. Note the color of the ferrous sulfate crystals and heat the boiling tube over the flame of a burner or spirit lamp, as you can see from the figure. Now observe the color of the crystals after heating. Now what we will be noticing here is the green color of the ferrous sulfate crystals has changed. Now you can also smell the characteristics order of the burning sulfur. Now in this reaction, you can observe that a single reactant breaks down into more simpler products. Now this is a decomposition reaction. Ferrous sulfate crystals lose water when heated, and the color of the crystals changes. It then changes to ferric oxide, sulfur dioxide and sulfur trioxide. So ferric oxide is a solid, while SO2 and SO3, that is sulfur trioxide and sulfur dioxide, are gases. And the decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction which is used in various industries. Calcium oxide is called quicklime or lime, and it has many uses. One is in the manufacturing of cement. Now, when a decomposition reaction is carried out by heating, it is called as the thermal decomposition. Now, coming to the other activity where there is a thermal decomposition reaction is seen. Now, take about 2 gram lead nitrate powder in a boiling tube and hold the boiling tube with a pair of tongs and heat it over a flame, as you can see from the figure. Now, what you will be observing in this case is, just note down the change, that the emission of brown fumes, the fumes are of nitrogen dioxide, and the reaction that has taken place, it forms lead nitrate, which gives lead oxide and nitrogen dioxide and oxygen. So finally the reactant is the lead nitrate, and it forms the product of lead oxide, nitrogen dioxide and oxygen. Now coming to the other activity where you take a plastic mug, drill 2 holes at its base and fit rubber stoppers in these holes. Insert carbon electrodes in these rubber stoppers, as you can see from the figure. Now connect these electrodes to a 6-volt battery. Fill the mug with water such that the electrodes are immersed, and add few drops of dilute sulfuric acid to the water. Take 2 test tubes filled with water and invert them over the 2 carbon electrodes. Switch on the current and leave the apparatus undisturbed for some time. You will observe the formation of bubbles at the electrodes, and these bubbles displace water in the test tubes. Now, is the volume of the gas collected the same in both the test tubes? Once the test tubes are filled with the respective gases, remove them carefully. Test these gases one by one, bringing a burning candle close to the mouth of the test tubes. Now, in this step, you must perform it carefully. Now, what happens in this case? Which gas is present in this test tube? Now, coming to one more activity, take about 2 grams of silver chloride in china dish, and what is its color? Place this china dish in sunlight for some time. Observe the color of silver chloride after some time. Now in this case, the white silver chloride turns grey in sunlight, and this is due to the decomposition of silver chloride into silver and chlorine by light. So silver bromide behaves in the same way, and the reactions are used in black and white photography. Now, what form of energy is causing these decomposition reactions? We have seen that the decomposition reactions require energy in the form of heat, light, or electricity for breaking down the reactant, and the reactions in which the energy is absorbed are called as endothermic reactions. Now, coming to the one more activity, which is of displacement reaction. Take 3 iron nails and clean them by rubbing with sandpaper. Take 2 test tubes marked as A and B. In each test tube, take about 10 milliliter of copper sulfate solution. Now tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in the test tube B for about 20 minutes. Keep an iron nail aside for comparison. Now about 20 minutes, take out the iron nail from the copper sulfate solution. Now compare the intensity of blue color of copper sulfate solution in test tube A and B, and also compare the color of iron nails which is dipped in the copper sulfate solution with one kept aside. Now why does the iron nail become brownish in color and blue in color of copper sulfate solution fade? Now in this reaction, iron has displaced or removed another element, copper, from copper sulfate solution, and this reaction is known as displacement reaction. Zinc and lead are more reactive elements than copper, and they displace copper from its compounds. Now double displacement reaction. Take about 3 milliliter of sodium sulfate solution in a test tube. In another test tube, take about 3 milliliter of barium chloride solution, and mix these two solutions. Now what we'll observe in this case is that a white substance is formed, which is insoluble in water. This insoluble substance formed is known as the precipitate. Now any reaction that produces a precipitate can be called as the precipitate reaction. So this is the example of double displacement reaction. Now what causes this? The white precipitate of barium sulfate is formed by reaction of SO4 2- and barium ions. So the other product formed is sodium chloride, which remains in the solution. Such reaction in which there is exchange of ions between the reactants are called the double displacement reactions. Now coming to the oxidation and reduction reaction. Now heat a china dish containing about 1 gram of copper powder. What do you observe? The surface of copper powder becomes coated with black copper oxide. Now why this black substance is formed? This is because of the oxygen which is added to copper and copper oxide. Now if hydrogen gas is passed over this heated material, the black coating on the surface turns brown as the reverse reaction which is taking place and the copper is obtained. Now if a substance gains oxygen during a reaction, it is said to be oxidized. And if a substance loses oxygen during a reaction, it is said to be reduced. So during the reaction, the copper oxide is losing oxygen, so it is being reduced. And the hydrogen is gaining oxygen and is being oxidized. In other words, one reactant gets oxidized while the other gets reduced during a reaction. Now such reactions are called as the oxidation reduction reactions, or also they are called as redox reactions. So from these examples, we can see that if a substance gains oxygen or loses hydrogen during a reaction, it is oxidized. And if a substance loses oxygen or gains hydrogen during a reaction, it is said to be reduced. Now, this is in the case of the example where the zinc and ZNO and CO, that is carbon monoxide, is reduced to zinc, and HCl is oxidized to HCl2, whereas MnO2 is reduced to MnCl2. Now coming to the corrosion. Now you must have observed that iron particles are shiny when new, but it gets coated with a reddish brown powder when left for some time. Now this is a process which is commonly known as rusting of iron. Some other metals also get tarnished in this manner. Now have you noticed the color of the coating formed on copper and silver? When a metal is attacked by substances around it such as moisture, acids, it is said to be corrode, and this process is called as corrosion. The black coating on silver and the green coating on copper are the examples of corrosion. Now corrosion causes damage to car bodies, bridges, iron nailing, ships, and to all the objects which are made up of metals, especially those of iron. Corrosion of iron is a serious problem. Now every year an enormous amount of money is spent to replace damaged iron. Now coming to the rancidity. Have you ever tasted or smelled the fat oil containing foods materials which are left for a long time? When fats and oils are oxidized, they become rancid and their smell and taste also change. So usually the substances which prevent oxidation, which are the antioxidants, are added to foods containing fats and oils. Keeping food in airtight containers helps to slow down the oxidation. So do you know that chips manufacturers usually flush bags of chips with gas such as nitrogen to prevent the chips from getting oxide? So this is all about the rancidity, and this completes the chapter of chemical reactions and equations. And if you have any doubts, you feel free to ask. And I hope that you are enjoying video. Thank you for watching.